Hello. In this video we're going to go through and solve a triangle. So the first thing we need to know is, what does solving a triangle mean? And what it means is that we need to find all lengths and all angles associated with this triangle. So the first challenge with this problem is communicating my answer, because this triangle isn't named, so it makes it very difficult for me to articulate what the different values are. So I'm just going to name this triangle. So to name the triangle, remember, we just have to name the three angles. We'll call this angle A, angle B, angle C. And then we're going to make sure we follow the appropriate convention, which is, if we name this angle A, this is length A. We name this angle B, this is length B. And if we name this angle C, this is length C. So you'll see I've had this little table here drawn to the side. One way to organize your answer is to make a table like this. And the first thing I do before I try and calculate anything is I write down what information is given. By writing down what information is given, it kind of helps me figure out a good course of action to take in solving the problem. So I see angle A is 37 degrees. I see angle C is 90 degrees. Don't forget that degree symbol. If we don't put a degree symbol, we're indicating that the measurement is in radians, which is another way of measuring an angle. And I see that length B is 8 meters. Okay, so now I'm free to kind of solve this triangle as I see fit. So let me change my color again. One thing I learned in university was that color coding answers helped me organize my thinking, as well as catch a lot of small careless errors. I typically am prone to small errors in my work, and through various things I've learned, I've had to develop techniques to try and avoid those small errors. So important to think about different strategies for learning as you're working through mathematics. Anyways, I'm going off on a tangent. So let me get back to the problem. So the first thing I'm going to do here, and I'll work through it in pink, is I'm going to find B. So we know there's 180 degrees in a triangle. So therefore, B is equal to 180 degrees minus angle C, which is 90 degrees, minus angle A, which is 37 degrees. And then I work through this, and I believe I should get 53 if I've done this right. Let's go over to my trusty calculator and check. 180 minus 90 minus 37, 53 degrees. Perfect. And now I take this and I write it in my chart. Excellent. Okay, so the next thing I want to do, well, let's find length A. So I know angle B and I know angle A, so I could use either of them, but since angle A was given to me in the problem, I'm better off to use angle A in my work. Because if I happen to make a mistake with angle B, that mistake is going to be carried through. So it's always important, if you can, try and use what's given to you. So we're going to use angle A. So I'm just going to jot a couple things on this triangle. If this is angle A, length A is going to be the opposite. And since I'm given length B, I want to know what that is, and this is the adjacent. So if I have the opposite and the adjacent, that's the tangent ratio. So 2, we're going to find A. So we know that tan of angle A, which is 37 degrees, don't forget that degree symbol, is equal to the opposite, which is length A, over the adjacent, which is 8. And therefore A is equal to 8 times tan of 37 degrees. So A is equal to, and now I'm just going to type this into my calculator, 8 times tan of 37, and I get 6.028 meters. So we have 6.028. Okay, so now at this point, I'm actually going to stop for a second. I'm going to ask myself a question, and that question is, does my answer make sense? And this is a check you should always do when you're working with triangles. And what my quick check is going to be is that I'm going to make sure that the angle length correlation makes sense. And let me explain what I mean by that. Often students will learn that across from the 90-degree angle is the longest side. The hypotenuse is the longest side of the triangle. But we can actually extend that rationale. Largest angle is opposite the largest side. The smallest angle is opposite the smallest side, and the middle angle is opposite the middle side. So notice, if we've done this correctly, my answer for A should be less than my answer for B, since angle A is less than angle B. And sure enough, it is. And there's some proportionality. If angle A and B happen to be equal, then length A and B will be equal. So this is a really quick check I can do to say, does my answer make sense? And because the mistake students often make here is they actually switch the A and the 8, and they work it out, they get an answer, but in that case, your answer length is not going to make sense if we do this check. Okay, last step. Last step is we want to find C. So lots of ways I can do this. I could, if I wanted, is I could use Pythagoras Theorem. So we know that C squared is equal to A squared plus B squared. So C squared is equal to A, which is 6.028 squared plus B, which is 8 squared. So C squared is equal to, actually let's practice our calculator work here. C is equal to the square root of 6.028 squared plus 8 squared. So C is approximately equal to, and so let's make sure, I would recommend, see if you can type this in your calculator in one step. So we're going to take the square root, there's the square root of 6.028 to the power of 2 plus 8 to the power of 2, and then I'm going to close that bracket, and I get a value of 10.017, approximately 10.017 meters, which I feel pretty good about. So, oh, I shouldn't have picked gray since this is gray. Oh well. We'll write in here in a different color. Let's write in green. So 10.017. I feel good about that. Now just a little comment about this step here. Remember, 6.028 is approximate, and therefore I should have an approximate symbol there. So if that length of A is an approximate value, by using this approximate value, I'm introducing some error into this calculation. There's no problem as far as giving this answer, to be perfectly honest, but you should understand that this answer is even more of an approximation because I've already approximated this value of A here. I'd say an ideal strategy here, or a better strategy, would be, since we're given angle A and length B, we're going to use our trig identities. It's not trig identities, sorry, our primary trig ratios. So C is a hypotenuse, and let's actually change my color to gray. I have the adjacent, I need to solve the hypotenuse, and so that's cosine. So therefore cos of 37 degrees is equal to adjacent, which is 8 over C. I can do a little rearranging here, so C is equal to 8 over cos of 37 degrees, and this is approximately equal to, let's type this in right here, 8 divided by cos 37 degrees, 10.017. So notice I get the same answer. Right? So it's not a big issue. But again, using this is technique 1 here. Let's just group these. That's technique 1. This is technique 2. By using technique 2, I'm using values that are exact and thereby reducing the amount of error in my problem. And though in this problem it's not a big deal, as you get into larger, more complicated problems, specifically in physics, you want to minimize error as much as possible. Anyways, it's over 10 minutes I've been talking now, so I think that's enough. I hope this video helped. As always, feel free to ask me questions or suggest problems. I'm always happy to help. Have a great day.